Ladies and gentlemen, welcome to ASIP 2020-2022, 38 years of ASIP.
Okay, last but not least, we're going to roll that into the NLign software suite for data capture and fleet management. Our presenter is Mr. Christopher O'Connell. Chris did not give me any a bio because he's humble, so I pried it out of him this morning. So this is my words. He graduated from Ohio University in engineering technology. He, right out of high school, joined the Army. And after that, he went to college, and now he's still in the Army Reserves to this day. So he lives in New Mexico. So anyway, welcome, Chris. Thank you.
Thanks. All right. Thank you, Chris, for that introduction. And thank you, Martin, for such a great presentation. Actually segues very well into what I'll be talking about, which is the benefits of the NLign software suite for data capture and fleet management. I hope I press the right button here. There we go. So the real reason I didn't give you much of a bio, Chris, is because I wanted to talk about myself up here. So I think you hit most of the main points. I've spent the last 5 years in the software industry, though. The last 3 years, I've been working for NLign, working on various NLign and NCheck implementations. So we're actually going to discuss one of those today. Quick overview of what I'll be speaking about today, really just setting a baseline for anyone who does not know much about NLign, who we are as a company, what our software does, and the like. Also going to discuss some recent advances that we've made to the software with a focus on data capture. Some of those features, I'm going to discuss the intended outcomes of them, and then also discussing what benefits those would have to various ASIP programs. The primary focus of my presentation will be on the NCheck tool, which is quickly gaining traction within the industry. I'll walk through some of the features we've developed recently and how they're being used. All of these features were developed for the C-130 commodities program down at Warner Robins, Georgia. These features now exist in our base product, though, and are available for use by anybody using NLign and NCheck. I do want to point out that the C-130 commodities group is not in full production using NCheck as of right now. We are still working on their rollout. Because of this, most of my findings and conclusions are going to be more anecdotal. So you're not going to see any fancy graphs or specific figures here just because a lot of the time studies have not been done yet. I will try to convey those anecdotal findings as objectively as I can, though. Before I get to that, I do want to, again, just set that baseline of what NLign does, who we are as a company, and what our software can do for you. So I'm going to apologize for anyone that is familiar with our company for the next few slides. But again, just trying to get everybody on the same page. As you can see here, we were founded in 2009 as a derivative of Edigent Technologies. We are rooted in the SBIR program, which is how NLign got its start. We have since developed the NLign tool and the entire software suite into a much more mature product. We are headquartered in Cincinnati, Ohio, and our motto is better data, better decisions, warfighter returns. So what does NLign do? We enable digital transformation by documenting the uniqueness of each individual aircraft. Essentially what we do is take data records from those individual aircraft and map them to a model according to what part or location that record came from. This allows us to build a very robust analysis tool around that 3D environment. This enables engineers to make better decisions throughout the life of that aircraft, or even using valuable information from the rest of the fleet when providing guidance on a single part or issue. I want to emphasize the importance of this bottom line here throughout the entire life cycle. We are trying to develop a cradle-to-grave record of each individual aircraft, so you'll have the entire lifespan right there in front of you when you're trying to provide analysis on a defect. Continuing off of that, NLign is trying to help aviation companies actually build that digital environment. We focus on the manufacturing, sustainment, and design industries. With this graphic, you can see that some of the biggest capabilities that we have that enable us to build that digital twin. The first bullet point is collecting data. That's actually going to be the focus of the rest of my presentation today. But we also map data and enable engineers to achieve analytical results. So our whole goal is to complete the digital thread. Until now, we've mostly focused on structures, but can theoretically support any different kinds of flight systems. From manufacturing to sustainment or cradle to grave, we acquire and store the data that makes every aircraft and component unique. We're also working to integrate with various PLM, MES, and MRO systems currently, and we provide that interactive 3D environment to aid in decision making. So the NLign tool takes care of the analysis side of the house. It's traditionally described as a 3D database. We saw some images of that from Martin's presentation just before this. So users can store and log information for specific aircraft or the entire fleet. It's capable of modeling and annotating various defects or damages, and it can theoretically be used for any kind of facility or aircraft component, and that is whether it has a 3D model or not. So I get this question a lot. We do typically work with 3D models, but if you have 2D drawings or even no models at all, you can still utilize NLign and NCheck. You just may not get all the visualization features. So in addition to collecting and modeling all of the data captured, we're able to use NLign to analyze that data, build charts, manipulate the data, and generate reports. This is where the usability of NLign is really showcased. Engineers are able to visualize what's going on across the fleet when making decisions with our hotspot analysis tools. The built-in reporting tools are also both very useful and time-saving. You're able to automatically feed data into an already created report as long as it's already built within the system. Last year, one of my colleagues actually presented on some of the tools that he was helping build specifically for the ASIP program. I believe that was in conjunction with Hill Engineering. We call it the standard trendable environment. The idea was basically that it would contain a certain data configuration, some dashboards, or what we refer to as workspaces, reports, and charts, all geared towards helping an ASIP group stand up the use of NLign very, very quickly. Now, as far as getting that environment to work, you still need to collect data from individual aircraft. As far as taking in data, NLign has several methods. You can either import bulk quantities of data, as well as entering in single records via NLign. As I mentioned previously, NCheck is going to be the main focus of this presentation. It is the other method of inputting data. As you can see here, it is completely separate from software pieces designed solely for capturing data. So this is an image of NCheck that we have a demo model in. Typically where NCheck is most at home is going to be on the shop floor in the hands of somebody who just needs to record information. Typically we're working with NDI inspectors, sheet metal workers, or really any kind of industrial process technician that needs to note what work they did or what they found. As you can see in this slide, this view of NCheck, you'll notice a few things. Number one is the model view that gives the inspector a 3D representation of the physical aircraft that they're looking at. They can draw on this model or annotate using a click and drag of a mouse, or they can actually just use their finger to draw right there on the model if they're working off of a touchscreen enabled device. That's actually what NCheck was originally designed for that touchscreen tablet. Then you'll notice some fields out on the left-hand side of the screen. These are custom fields that are simply there to help better characterize whatever finding we're trying to capture. Again, this is just a high-level overview of NCheck. Just wanted to set that baseline before we start deep diving any new features. So it is a companion application to NLign. So two different applications, two different purposes. They do access the same database though. That means that it feeds all of that data into the same location. And it's done almost instantly as long as NCheck is hooked up to secure internet. It is streamlined and designed for inspectors to input data as quickly as possible with a simplified user interface. We actually use fields that can also prevent bad data from being input or incomplete records from being put into the database. That's a little bit more about what Martin was talking about in the last presentation. So that's all great, but why do you care as ASIP engineers? Basically because we have a long history of working with various programs, all geared towards supporting ASIP. As you can see here, we started in roughly 2012, helping the A-10 and T-38 programs. Eventually, we've been adopted in some form or function by many different Air Force groups as well as OEMs. In recent years, we've made huge strides in our data collection tools, all in support of various ASIP programs. So with feedback from these programs, we've developed new tools for capturing data directly in the NLign environment. The driving elements of these enhancements were to increase the speed and accuracy of data being captured on the shop floor. Basically, what I'm saying is that we realized that we had a very powerful analysis tool with NLign, but it just didn't have the gas to get anywhere, right? It had a lot of power and capability, but without the data, it's got nowhere to go. We needed to enable shop floor workers to better supply data to NLign, or else it becomes a worthless tool to the engineers. You can't run analysis on nothing. So we set out to make it as easy for the inspectors to get data into NLign as possible. So finally, we're getting to the new stuff. Again, I'll apologize for that background information to those that are familiar with our company. You just never know who's sitting in these rooms, and the only thing worse than hearing something that you've already been told is being clueless about what somebody is presenting about. So the next few slides are going to outline the new features that we've developed, listening to the workers in the Air Force CMXG shop down at Warner Robins. All of these features were developed basically using the requirements that they gave us directly. So this particular feature is what we refer to as defects from a legend. As you can see, it enables a user to draw a defect from a model using predefined symbols for corresponding defects. The defect type is selected from a newly developed legend at the top of an NCheck details screen. I believe you can kind of see it there. So different symbols have been selected for each different kind of defect. Once a selection is made, a user will simply drag and drop the symbol on the model. This simultaneously marks what defect has occurred as well as where it happened. So this feature allows users to very quickly enter data. They no longer need to open a new field or worry about the exact location of a defect because they're really just outlining an area. Engineers get a lot more clear of a visualization of what defect is or has occurred without needing to read different fields as well. And finally, we are making process improvements, not process changes. We developed this feature, like I said, in conjunction with the Air Force's C-130 commodity shop to help them digitize some of their inspection processes. We found that even with a pen and paper, they were still able to enter data a bit faster than with our system previously. Even though it was often less accurate and harder to find, the inspectors were still happier with it because it didn't affect their throughput at all. They were able to do this faster. So what did we do? We went ahead and digitized their method as well. We figured that the Air Force spent good amounts of time and money developing this process, as well as the workforce and training materials in order to support it. So why should we change anything? We found that with this feature, they have a very similar time to record defects as with their previous system, but with all the added benefits of using a digital environment while ensuring that data was recorded correctly and completely. Also developed in conjunction with the C-130 program was the ability to view multiple defects from a single model view. Previous versions of the NCheck tool had this annoying limitation of only being able to view one defect at a time, and that was the defect currently being captured. In some cases, this was just a minor inconvenience. In others, it would actually cause a large waste of time. As is common practice, inspectors were trained to ensure that all previous inspections had been completed before doing their work. They also may pay closer attention to areas that an indication had been found previously along this work path. In previous versions of NCheck, this could have meant scrolling through a list of defects, trying to decipher what had been completed, or flipping through all of the findings detail screens. With their previous with their previously held paper method, they would actually have to go through this process of flipping between sheets to ensure that the work was done. Unfortunately, because aircraft components vary widely with what they're brought into depot with, it was difficult for me to get a time estimate of how much or how long this process of flipping through findings would take. But needless to say, it was a waste of time regardless. This also opened up the possibility that the same defect would be recorded multiple times. Totally unnecessary. It also became difficult to ensure previous worker inspections had actually been completed, as it was often difficult to see what had been captured from the job landing page. So again, what do we get out of this feature? Based on what we've seen again on the C-130 commodities, this would reduce the risk of dual or multiple entries of the same defect compared to previous versions of NCheck. It also reduces the amount of time wasted overall, as inspectors no longer need to manually flip between pages, ensuring that all previous inspections were completed. And as expected, the inspectors get a better understanding of the previously recorded data right from the model. They no longer need to go through and actually flip through all of the previously recorded findings. And the last feature I'm going to discuss is probably the most innovative. Our new task system is a feature that enables an engineer to create a predefined process path of various tasks within NCheck. Any given task could be an inspection or basically just work required to be completed before a job is marked complete. This capability effectively lets NCheck run on a continuous basis for all routine work across a shop floor. This is especially useful in depots where maintenance is seen on a production level. So, for instance, we have this list of tasks here that are populated automatically in NCheck. This could be for any component or aircraft that comes into depot where you have a list of inspections that it needs to undergo. Whereas in previous versions of NCheck, a job would actually have to be created for each one of these tasks. Now, we've got all of the overhead information available right there. So the job level of the inspection allows all of the overhead data to be captured one time and applied to all of the findings. This could include information that will not change over the course of the working period, such as serial numbers or flight hours. This helps us from having to re-enter any of that information multiple times, as we saw with previous versions of NCheck. So again, when we developed this, it was designed for the C-130 commodities program with depot level maintenance in mind. We set out originally to save time by keeping the inspectors from recording overhead information multiple times and to get a better flow of products across the shop floor. Over the previous instances of NCheck, about a minute per component was actually saved just by not requiring them to re-record their overhead information. For every NCheck inspection, that amounted to about 10 minutes of work per component that they were passing through. We found that in addition to these benefits, we actually enabled the inspectors to have a constant mesh of information being fed to them. They're better able to predict what work they had coming in and could more efficiently use their time because of this. They're able to plan a little bit better. The task system also allows engineers to understand what is going on with the products that are currently on the shop floor without the need to hunt for paper documents or through other systems for the information that they need, as it's all readily available within NLign. What we see with the current system down at the C-130 commodities program is actually a lot of pieces sitting around the shop floor waiting for a disposition or for an inspector to alert an engineer or supervisor that an indication has been found. With data being recorded directly into NCheck, it only takes a few button clicks in NLign for an engineer to see what defect was found on a specific component and what inspection actually caught that defect. The engineer theoretically no longer has to be in the same building or really even on the same base as with previous data capture methods. So intended to save time, reduce effort, and increase efficiency for the data capture process, all these features are in addition to the existing NCheck product that was proven to be a successful data capture solution for various platforms within the ASIP reporting community. Before I close out, I do want to drive one last thing home, And that is how we are adapting our systems to meet the needs of our customer base. For those of you that attended AA&S this year, one thing that was repeatedly brought up was the need for adequately trained and competent maintenance personnel. It is very difficult to adapt existing standards and practices while also training a new workforce. The push for the digital twin and digital thread is going to be a major overhaul to existing practices. That is why we are striving to remain as consistent with existing workflows as possible. Our hope is that the integration of NCheck into any depot or shop is so seamless that the inspectors barely realize that it's even happened except to recognize the benefits. So I want to thank you all for your time. This is only my second time that I've ever attended ASIP, so it's a huge honor for me to be able to speak with you all. Before I open up the floor for Q&A, I would like to mention that I'll be at the NLign booth for the rest of the conference, so if you'd like to chat with us there, please feel free to stop by. But at this time, I'd like to open up my remaining time for questions and answers. Thank you.